Okay, so good afternoon again. In this segment, we're going to go over an example of how the derivative can be used to determine the slope of the tangent line, and actually also not just the slope, but the equation of the tangent line to the function y is equal to x squared and x equal to 1. So we're determining the slope. We're also going to use the slope We're going to use the slope to determine the equation of the tangent line to y is equal to x squared when the input is equal. Now, how do we do this? Well, the first step, remember the slope from last video was equal to the derivative of the function f of x is equal to x squared at x equal to 1. So step 1, compute f prime of 1. If you recall from the definition of the derivative in the first video, the derivative of the function at x equal to 1 is the limit as x approaches 1 of f of x minus f of 1 over x minus 1. This is equivalent to the limit as x approaches 1 of x squared. Remember, f of x in this case is the function. F of x is equal to x squared. So you can also say that y f of x is x squared. That's what we're using here. F of x is x squared. So we plug in 1, we get 1 squared, which is 1. Down here, this is the difference in outputs. This is the difference in inputs. Limit as x approaches 1 of x squared minus 1 over x minus 1. X squared minus 1 factors into two factors. One is x minus 1, the other one is x plus 1. It's the difference of two squares. We've seen this before. X minus 1 over x minus 1 is canceled. So what we're left with is limit x goes to 1 of x plus 1. What do you get when you plug in 1 to x plus 1? You get 1 plus 1, which is 2. So this, the only thing new for you actually should be this. This should all be reviewed because you've computed limits on your last midterm. Okay? Okay, so the first step was we determined the slope of the tangent line to y is equal to f of x, which is equal to x squared at x equal to 1. That slope we found was the limit f prime of 1, limit x goes to 1 of x squared minus 1 over x minus 1, we found it was equal to 2. So this is our answer for the first part of the problem. Step 2, we're going to use this point slope formula to get the equation of the tangent line. Now, to do that, I need to explain the point slope formula, which I will be doing in the subsequent video. Okay, so step one, we determined the slope of the tangent line to y is equal to f of x, which is x squared, and x equal to 1. We found the slope, which was f prime of 1. The limit as x goes to 1 of x squared minus 1 over x minus 1 was equal to 2. That is the slope of the tangent line to the function y is equal to f of x, or x squared, at x equal to 1. Now, the second step is to use the point slope formula to get the equation of the tangent line. Now, I haven't described the point slope formula in depth yet in class. I will do it for you now. Equation of a line, lines can be determined by two pieces of information. One is their slope, the other is the point they pass through. The equation of a line that has slope m and passes through the point x1 comma y1 y minus y1 is equal to the slope m times x minus x1. Now, to apply it in our situation, use the point slope formula to get the equation of the tangent line. Well, what do we already know? We already know that our slope, what was our slope? M was f prime of 1, which is 2. What's the point this tangent line has to pass through? It has to touch the curve at the point on the graph where the input value, the x-coordinate, is 1. When the x-coordinate is 1, what is the y-coordinate? So that y-coordinate is 1 squared, which is also 1. So this should be general 1 comma f of 1, 1, 1, because in this case our function is, well, f of x is x squared. So when x is 1, f of 1 is equal to 1 squared, which is 1. And then we just plug everything in. Now, if you want, you can rewrite this in a slope-intercept form. Y is equal to x plus b. By distributing 2x minus 2, add 1. Minus 2 plus 1, that's the same as negative 1. So this is 2x minus 1. Now, if we were to draw this, what does this look like? So as you can see, the parabola is the curve y is equal to x squared. The tangent line is the line y is equal to 2x minus 1. It has y-intercept negative 1, and it passes through this point 1 comma.